Ed continued his questions by asking about what the home life is like for a scientist.
We both need a wife. I need a wife, or not in the sexist sense, but a housekeeper, someone who's home. He's a professor at MIT, and we both work 12 to 14 hours a day, and we say we're going to come home, but then you don't even know you're doing it, and you look up and it's 9 p.m. and you go, oh my goodness, I'm starving, it's time to go home. And then you get home and you open macaroni and cheese, and we have standard dinners: Kraft macaroni and cheese, frozen Mexican TV dinners, what's another one? Probably hot dogs. I mean, we're just not there. It's a problem, and it frustrates me because I keep saying I'd like to have more of a normal life, but I love what I do, and I can't really be where I'm at doing what I'm doing in too many fewer hours. It's a problem for having children for women. This is a big issue because your graduate school career and then your postdoc and then your assistant professor all happens during childbearing years, and it's just, there is not time to stop, and it's interesting.
Colleen and I were graduate students together. In fact, we had the same advisor. I asked her to tell a story I remembered from graduate school. Now, when I was a graduate student, I remember a little period of time somewhere around 1980 where all of a sudden there was a number of weeks where you were running around frantic saying, I think I've got it, I think I've got it. Now tell me what was going on back then.
Actually, when you asked Cindy and Ruth about the intense period of time of learning, that was one. I proposed this symbiosis in a course that our advisor Ken Stevens, Jim McCarthy, and Ruth taught, the Nature and Regulations of Marine Ecosystems. And at the time, Meredith Jones, who was lecturing on the anatomy of these 6-foot-long tube worms that had no mouth and no gut, and one of the questions was, how are they feeding? And he had found elemental sulfur crystals in a tissue that fills the cavity of the worm. And it was at that point that I jumped up and said, well, it's clear they must have symbiotic sulfur bacteria inside of their tissues that feed them internally, just like zooxanthellae, phytoplankton in corals and chloroplasts in plants. And he was like, no, sit down, kid. We think it's a detoxifying organ. I was like, that's fine. They can take hydrogen sulfide, which is toxic, and convert it to elemental sulfur and make energy in the process, and everything's hunky-dory. So he really didn't believe it. Ruth was pretty enthusiastic, but he sent me tissue, and as a first-year student, I used microscopy to try to prove that there were bacteria there, and that was when I didn't know what I was looking at, because they didn't look like E. coli. They didn't look like what you would think bacteria look like. And so I was using light microscopy, and then I used scanning EM, and everything looked like a bunch of grapes in this tissue, just hundreds of grapes, thousands of grapes. And it took thin sectioning right through the tissue to show that that they were bacteria, that they had cell walls like bacteria. And that was the final thing that finally said, yes, they really are.
Did you really jump?
I literally stood up, I think.
Yes, you did.
Because it was a small seminar class, and said, I mean, it just made perfect sense. Now, you have to understand that I'd been working at Ecosystem Center, where there was a whole group working on the sulfur cycle and thinking about sulfur cycling. And we'd had a whole series of talks. Ruth gave a whole overview of the ecology, Holger Janisch on the microbiology, Russ McDuff on the chemistry. So I'd been thinking about sulfur, and I'd worked for John Hobby and thought nothing but bacteria for 2 years before I went to graduate school, which are my passion in life. That was the other thing I wanted to be remembered for, was how important bacteria are.
How important are they?
They're everywhere. They keep everything going. And I was so convinced that everything made perfect sense, but it was an uphill struggle to convince other people. People really didn't believe it. Holger Janisch, and they made me jump through hoops to prove it, which is what you need to do in science anyway. But it was a...
Did you think any of those hoops were unfair?
Not the scientific ones. The political ones, yes.
Mm-hmm.
But those were resolved in the end.
I was curious how much exploration remains for the deep sea. Are there any vent sites that haven't been explored yet? I mean, there's a lot of vents around the world. Are most of the interesting ones already explored?
Hardly. I mean, all the ones that have been explored are interesting, but we've only seen a fraction of the spreading centers. in the ocean. So there's tons to see, and especially in isolated places like in the Indian Ocean or the Arctic Ocean, or places where we haven't even come close to.
Any of those
seeing
likely to
things.
be more interesting, or as interesting as the ones we've seen already?
All of them, yeah. There's no knowing till you go and look.
If you could go anywhere right now, where's your number one priority?
Indian Ocean.
Yeah?
Yeah.
Where?
On the Indian Spreading Center, right in the middle of the ocean.
And why is that?
Well, there's at least some biogeographical reasons. We know what's in the Atlantic, at least in two sites, and we know the sort of general fauna in the Western Pacific and the Eastern Pacific and Juan de Fuca, and the Indian Ocean's been separated or isolated from those areas, and you just wonder what are you going to find there? I mean, it's up for grabs what animal's going to be there. Is it going to be shrimp or tube worms or something entirely different? I mean, who knows?
No one's been there yet.
No.
No.
So that's genuine exploration awaiting.
Absolutely, yeah.
If next year they come up with the perfect automated submersible that can go down and do everything that Alvin is able to do, you think you'll retire from being a pilot?
Oh, I mean, what you get is going to be video images, and they haven't made a video camera as good as the eye.
No.
Yet. And to go to the seafloor, you may not need to do it to get the scientific data, but to get the stuff in your brain that gives you the imagination and the creativity. I mean, you'll get something on shore with a video image, but it's not like being there.
No. I've done both now, and I always thought that these robots and rows were useless. They're not useless.
Oh, hardly.
But the excitement and all that you get by being in a submarine, it just isn't there. You're on the deck of a ship and you're seeing stuff on a video screen, and it's not there. I agree with it's completely.
I finally got down for my first dive and had seen the videos of the site and had heard the description, the voiceovers and everything. But until I saw them, the animals, and the way the sand changed from black to white to tan within a space of a foot, out my little porthole looking down like this.
There's just nothing.
It made all the difference in the world. And the excitement. I mean, I would go down in the sub every day. I wouldn't trade it for anything. It can't compare. I'm not saying they're not useful, for heaven's sakes, but it can't compare.
I asked whether they might have any advice for students potentially interested in studying marine biology.
Do what sets you on fire. And if you do it, you'll be a success. But if you try being a specialist in a field that you only feel so-so about, you're never going to be a success. And I think that's pretty true.
Yeah, I would say get in a lab, get in the field, and do something. Do something yourself. I find I'm very frustrated by undergraduates who come, who get all the way through 4 years, and they have never been in a lab because they didn't even think about it. They've never done any biology. And the other side of that is the students who don't have any internal questions or any motivation. They say, what do you want me to do? What do you want me to do?
We let Ruth offer the final comments of the evening.
Well, for me, it's every bit as exciting as it was the first time I ever started. And I'm sure it would be for any of the very early scientists, because it's just a very exciting, ever-changing field. And anyone who says that even systematics is a dead science, all they need to do is go down in the deep sea, and you've got a whole mess of new animals. I've got a load of them on my desk that I have no idea what they are. I can put them into amphipods and isopods and things like this, but to get them much below that, I'm going to have to go to Washington, and probably won't get them until I find what I do generally is just collect these things together. Somebody comes along, a graduate student or a specialist who is particularly interested in this group, and I say, here, take them away. Best part of science? Being paid to go to work or whatever and do the thing you most want to do and getting paid for it. And I've done that for many, many years and had a wonderful time. What more can you ask? And having students like Colleen.
Thank you.
deep sea, the deep, deep sea. It's a dark and lonely place. The deep, deep sea, the deep, deep sea. As vast as outer space. Well, you don't drive there, you don't take a train. Deep sea. And if you do, you don't come back. Deep sea. A submarine's the only way to go. But where the windows do not crack.